Welcome to the mathematics class. Today we'll be looking at number bases. The very first thing we need to understand in number bases is how to convert from base 10 to other bases and from other bases to base 10. With conversion, you can solve virtually all the questions under number bases. Let us look at how to convert from other bases to base 10 using a very fast method. Conversion from other bases to base 10. Okay, the method we are using is called the coded decimal method. In the coded decimal, you are expected to generate a code for all the bases in base 10, so that if you need to do conversion, you can easily use the generated code. How do we generate the code? Example, if I'm working in base 2, for example, remember base 2 numbers are called binary numbers. The code for binary numbers, you start from your right hand side. The first code is always 1, no matter what the base is. The first code is 1, then multiply by this code by the base. This is base 2. If I multiply 1 by 2, I'm going to get 2. Multiply this by the base also. Multiply 2 by 2, I'm going to get 4. Multiply this by 2 again to get the next code, that's 8. Multiply this by 2, get the next code, 16. So that means for base 2, the code will go like this. For example, in base 2, somebody tells you to convert. Look at this example. Convert 11011 in base 2 to base 10. If you have to do this, the first thing to do is to generate your code. I have my code already. How many digits do I have in this question? You count it very well. I'm going to have 5 digits there. I have the first one, the second one, 0, 1, and 1. So my code will go like this. I'm going to generate 5 different codes. 1, since I'm in base 2, 2, 4, 8, and 16. How many codes do you have on the screen? 4. Thank you. 5. Sorry, don't mind me. Okay, converting this, the first digit is 1. I place it under the first code. Second digit is 1 under the second code. 0 is the next digit under the third code. Then the next digit under the next code, and the next one under the next one. Now what do I need to do? I multiply. 16 times 1 gives you 16. 8 times 1 gives you 8. 4 times 0 gives you 0. 2 times 1 gives you 2. 1 times 1 gives you 1. Add all this together, you are going to get 27. That means this 11011 base 2 is 27 in base 10. Hope you understand that. Let's look at another base. It goes for all bases. It is not just for base 2. Let's say I I want to try it for base 3. Then for my base 3, look at base 3. The first thing is I generate my code. Somebody gives me convert. This is a question. Convert 1 2 1 2 in base 3 to base 10. If I have to do this, what do I need to do? I generate my code for base 3. How many digits do I have in this question? I have 4. 1 is the first digit, 2 is the second digit, 1 is the third digit, and 2 is the fourth digit. So generating a code that will take care of 4 digits, the first is always 1 from your right hand side. Remember, 1. Then multiply this one by the base. This time around my base is 3. 1 times 3 gives me 3. Then multiply 3 by 3, 9. Multiply 9 by 3, 27. In this case, I have my 4 codes already. So I have to place my digits under the codes. 1 is the first digit, it goes under the first code 27. 2 is the next one, it goes under the next code 9. 1 is the next one, it goes under the next code 3. And 2 is the next one, it goes under the next one 1. Now do your multiplication. 27 times 1, by the grace of God, is going to give you 27, whether you like it or not. 9 times 2 gives you 18. And 3 times 1 will give you 3. Then 1 times 2, by His grace, you are getting 2. And then you add all these things together, you are going to get 50. So that means this conversion gives you 50 in base 10. I believe this is simple enough, and that means you can convert from any base you like to base 10.
Okay, sir. I actually have a question, sir. Please, can you kindly show us how you got 27 plus 18 plus 3 and plus 2? How, for instance, if I don't know how to do the addition, can you kindly show me how to do it? Like 27, how do you get this 50?
Okay, if you are solving maths, you have to be very sharp. Mathematics is not meant for people that cannot think fast. Your thought must be very fast. Look at 27. By the time you had this 3 to 27, by the time you had this particular 3 to this your 27, that will give you 30. By the time you had 18 and 2, that gives you 20. 30 and 20 gives you 50. That is how you do the addition. Thank you. Shall we continue? Now, you can also convert from base 10 to other bases using this code. You can also convert from base 10 to other bases. Conversion. Don't mind my handwriting. Conversion from base 10 to other bases. It's also the same way, but with another method of application. Like, for example, I'm going to go back from my answers in the first example so that you really see what we are talking about. In the first one, the answer we got was 27 in base 10. So let us convert 27 from base 10 to base 2. Let's see if that is going to give us 11011. Somebody gives you a question like this that says convert 27 in base 10 to binary. I'm sure you still remember that the name we give to base 2 numbers is binary. Convert 27 base 10 to binary. the first step is the same thing as the first step in our first parts of the class. That is conversion from other bases to 10. Now, what base am I going to? That's the first question you ask yourself here. If you look at the first one, the base I'm going to now is base 2. So I'm going to generate the code for base 2. 1, 2, 4, 8. What's the next one?
10.
You are not serious. 16 multiplied by 2.
Okay.
It gives you 16. Good. But in this case, the next code is going to be 32, which is already more than the number I have in the question. So I don't go beyond that number. You are not supposed to put any code that is up to the number given to you in base 10 or more than that number.
That is 27.
Yeah, you can see you are given 27.
Okay, so
Immediately you put the next one 32, it's already more than your 27. So you don't include it.
Okay.
That means I have to stop here.
okay.
So what is the next thing now? How many 16 will I see in 27? I'm going to see 1.
1.
If you remove 16 from 27, you are going to get 13.
13. Okay.
Is that correct?
Yes.
Yes, 13. Remove 8 from 13. How many 8? Just 1.
Yes.
Leaving behind what?
5. Minus 5.
Okay. 5. Okay, how many 4 will I see in 5?
1, sir.
1. Leaving behind 1.
1.
I can't get 2.
Yes, sir.
I think there is a mistake somewhere. I can't get 2 in 1 since 2 is already more than that. I'll put 0 for it. Then 1 in 1, that's going to be 1. I think there is a mistake somewhere. We need to check it out. Now here, by the time we had 16 and 4, okay, there is a mistake. There is a mistake. Because this addition itself, what I've just done here, this addition is going to give me like 29. So this is very wrong.
Okay, the
1,
total
2,
number
4.
of the 5 must give us 27. No?
Yeah, it must give us 27.
Okay.
So 16 removed from 27, that is not going to give us 13. Sorry, it's going to give us 11.
Okay, sir.
That is 11. You can see now, we can't afford to make mistake. Okay, that gives me 11. So I will see, I can see 1 8 in 11. Correct. Sorry, I'm sorry, let me quickly remove this error so that you don't study error. Okay, now in 11, how many 8 can I see in 11?
1.
1. Leaving behind 3.
3.
4 is too big for 3. I can't see any 4 in 3. How many 2 will I see in 3?
1.
Leaving behind 1. How many 1 will I see in 1? 1. So my answer is now 1, 1, 0, 1, 1 in base 2. Thank you very much. And that is how you do the conversion. But I need to show you more things under this conversion. You know, if I'm dealing with base 2, I can only pick a code once. If I'm dealing with base 3, I can pick a code 2 times, once, or I don't pick it. If I'm dealing with base 4, I can pick a code 3 times, 2 times, once, or I don't pick it. If I'm dealing with base 5, I can pick a code 4 times. I cannot pick a code at a time equals to the digits of the base. Like for example, if I'm in base 2, the digit of my base is 2. That is how we call it base 2. So I cannot pick a code 2 times or more than that. So that means the maximum is just 1. I can only pick it once. If I'm in base 3, the digit of my base is 3. I cannot pick a code 3 times. but I still have the privilege of picking it 2 times, once, or I don't pick it. What I'm saying in essence is, look at this question. It says convert $19 in base 10 to base 3. How do I do this? Okay, I'm in base 10. I want to go to base 3. So I'm going to generate coded decimal for what base?
Base 3.
Good, thank you for base 3. So the first code is always 1 from your right. Multiply it by 3, you get 3. Multiply this by 3, you get 9. If you multiply 9 by 3, you're going to get 27, which is already more than my 19. So I don't get there. Okay, since I cannot get there, I have to manage these 3 codes for my 19. So how many 9 will I be able to see in 19?
2, sir. I
can see 2, thank you. So 9 times 2 gives me 18, leaving behind 1. 3 is too big for 1. I can't pick 3. Then I can see this one once. Sorry, I can pick this one once. So that means my answer is what? 201 base 3. So that is the conversion. So that tells you that you can convert from any base to base 10, and you can convert from base 10 to n base. So any operation they give you in number basis, you can use conversion to solve it. Like for example, you have this question that look tough, but I tell you it's a question you will see, and you go and collect a bottle of Pepsi, drink it, relax, then solve it, because it's very simple. Look at this. This question says simplify 1110 base 2 multiplied by 112 base 3, then multiplied by 61 base 7. Now say leave your answer in base, leave your answer in base 2. So I need to do this. It's also very simple. What do you need to do? The best way to do this is convert all these guys. How many things do I have? You have 3 things. One is in base 2, one is in base 3, and the other one is in base 7. Let me convert the one of base 2. Coded decimal for base 2 is going to be 1 multiplied by 2 multiplied by this. Next one is 4. Next one will be what? 8. I have to stop because I have only 4 digits. So I have 1 1 1 0. So that is 8. This times this 4. This times this 2, and this times this 0. This is going to give you 14 in base 10. The same thing, look at the second one is in base 3. Generate coded decimal for base 3. 1 3 multiplied by 3 9. You understand? Okay, place the digits. I have 1.
We will go to the next page.
Okay, all right. I have these 1, after 1 3, then 9. What I have in the question was what? I think 112. Okay, let's move on. 112 base 3. Okay, I can go ahead to solve this question. That is it. 112 in base 3. So I'll say I'm going to put the first one. The first one, we have to go under 9. Don't forget. The second one, we go under 3. then 2 will go under 1. That is 1 under this, 1 under this, and 2 here. 9 times 1 gives me 9. 3 times 1 gives me 3. 1 times 2 gives me 2. By the time I add all these things together, I am going to get 14. So that means this number is 14 in base. Now the question we were solving, 1110 base 2 multiplied by 112 base 3 multiplied by 61 base 7, and we have been able to convert 1110 base 2. We have been able to convert 112 base 3. You know, the first one we got 14 in base 10. For the second one, we also got 14 in base 10. Now let us convert 61 to base 10. 61 is in base 7. So let's generate a coded decimal for base 7. That's 1. That's going to be 1 and 7. Then place the digits. 6 stays under 7. Then 1 stays under 1. 7 times 6 becomes 42. Then 1 times 1, that's going to give us 1. 42 plus 1 is giving us 43 in base 10. Why are we converting to base 10? Because we are familiar with multiplication in base 10. Now, to solve this, what we just need to do now is to multiply all these 3 answers in base 10 like this. The first answer was 14, the second answer was 14, while the next answer is 43.
Okay, you converted all of them
to base 10. Thank you. Okay. After converting all of them to base 10, multiply them normally in base 10.
Okay, the way it was on
yeah, the way your normal multiplication. If I ask you 21 times 10, you will say 210. That is in base 10. 21 in base 3 times 10 in base 4 will not give you 210. It's going to give you another 10. Okay. So we are using base 10 here, and we are all familiar with base 10. So as a result of that,
14 is 196.
14 times 14 will give us 196, and 196 multiplied by 43 gives us what?
8,428.
8,428. Don't mind all these answers. After the whole explanation, I'm going to solve some questions from different schools post UME. You will see how it looks like. Now, they said you should leave your answer in base what? Base. You have to leave your answer in base 2. So that's going to be a very big answer. It's going to be a very big answer. So I'm going to convert this number to base 2. Wow, this is too big, but we'll do it. 8428. So generate the coded decimal for base 2 that we are going to. The first guy will be 1, next guy 2, next guy 4, next one 8, next one 16, next one 32, next one 64, next one 128, next one 256, next one 512. This is too big. Next one
1,224.
1,224. Next one
1024.
1024. Go on. The next one
2048.
You see, is really crazy. Next one
4096.
You know, the next one 4096. By the time you look for the next one, It gives me what?
The next one is 8192.
Okay. I can still get the 8192. You know, the next one will be 16 something, and you know. So if I pick this 8192, I see only one in my answer. Don't forget, I don't want you to forget that answer. Let me take you back there. The answer we got was 8428. Please keep it in your mind. 8428. I pick one of these, so I have one. I can get 18192. It's going to leave behind what? Remove 8192 from 8428.
That will give us 236.
236.
Yes, sir.
236. Let's keep it here.
Okay.
This 4096 is already more than 236. I don't pick it. I'll put 0 in its place. That means 0 follows this my 1. This 2048 is also bigger. 236. I don't pick you. That means I'll have 0 again. 1024 is also bigger. I don't pick you. 0 there. Even 512 is bigger. Look at my funny 5. 512 is also bigger. I don't pick it. 0 represents it. 256 is also bigger. I don't pick it. I put 0. 128. I can get 1. Leaving behind what? You say 236 minus 128.
236 minus 128. That will give us 108.
108. That's what I have left now. How many 64 will I see there? 1. Leaving behind what? You say 108 minus 64.
That will give us 44.
44. Okay. How many 32 will I see in 44? 1. Remove 32 from 44. You're going to get 12. Can I get 16 in 12?
No, sir.
That's not possible. 0 represents it. How many 8 will I see in 12? 1. Leaving behind 4. Abi?
Yes, sir.
How many 4 will I see in 4? 1. Leaving behind nothing. Since there is nothing left, these two guys, 0 represents them. So you can see it's a very crazy answer. Don't mind it. It is the procedure that matters. So the answer is what? The answer finally becomes what?
1.
Answer is 1 0 0 0 0 0 1 1 1 0 1 1 0 0 in base 2. That is how you solve this kind of question. Let us go to the last part of number basis, and that is number base equation. That is number base equation. Number base equation. Number base equation. Now, since you are writing post-UTME, we are going to be using short methods to get our answers, since you don't have enough time for solving questions in this exam. So you need to be thinking of how to get the correct answer as early as you can. Now, if you have to solve a number-based equation, the best way to solve this one is to use a try and error method. What is try and error method? The method requires you to use the options to predict what your answer will be. Like, for example, you're given a question like this: if 2 2 1 base y is equals to 25. Then find y. If this is the question and you have option A, you have option A. Let me correct this. This is not well written. So let me write it again so that you can see it clearly. Now let's say we have option A as 4, option B as 5, option C 3, then option D probably 2. So we have to solve this. The best way to do this is use all the options. If 4 is the answer, then 2, 2, 1 base 4 should give me 25 in base 10. So let's try and look at that. Will it actually give us 25? Generate the coded decimal for base 4. This is 1, 4, 16. Since I have 3 digits, I'll stop. Place my first digit here, second digit here, and third digit here. 16 times 1 is 32, 4 times 2 is 8, 1 times 1 is 1. This is giving me what? 41. So this cannot be the answer, since what I have at the right hand side here is 25. So let us try the second option. 2, 2, 1 base 5.
And it's 5 can never be it.
It cannot be 5. Generate decoded 1, 5, 5 times 5, 25. 2 stays here, second 2 stays here, and 1 stays here. This gives you 50. It's already more than 25, so don't even think about this. So try the next one. Try the next one using 3, 2, 2, 1 base 3. So let's look at it. 1, 3, 9. So this is 2, 2, and 1. 9 times 2 is 18. 3 times 2 6. 1 times 1 1. This is going to give you 25. So this is the only option that gives us 25. So as a result, I don't need to do any solving. I'll just go ahead and choose option C as my answer. This is how you solve this kind of question. At times, they want you to do the conversion of decimals and fractions. They are also very straightforward. Our code can still take care of all those things. How do we do the conversion of decimals? So the way you generate their own code is this. They have numbers that are in decimals. Take note of the fact that numbers in other bases can be put in decimal, but number in base 10 you put it in fraction. So like for example, somebody asks you to convert 0.1101 in base 2 to base 10. In this one, if you look at it very well, is in decimal. So everything you see after this decimal point, they are not up to 1. So if I want to do the conversion of these guys, their own code is this. Instead of going to start from the right, like what we did for integers, For these ones, I'm going to start from the left, and is the first member will be 1 over my base raised to power 1. The second one is 1 over my base raised to power 2. The third one is 1 over my base raised to power 3, and I continue like that. Next one is 1 over my base raised to the power of 4. That's how you continue. Like I have 4 things here. So 2 raised to power 1 is going to be 2, because any number raised to power 1 is that number. 2 raised to power 2 is 2 times 2, that's going to be 4. Then 2 raised to power 3 is 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. 2 raised to power 4 is 16, because 2 times 2 4, 4 times 2 8, and 8 times 2 is 16. You can see that the codes we use for integers are now appearing as the denominators, with the exclusion of 1, which is the first person. If you look at the coded decimal for base 2, we started with 1 from the right hand side, followed by 2, followed by 4, and we are coming towards the left.
Okay.
So if you look at this one now, there is no 1, and we start from the right, then the code goes from the left, and the code goes towards the right. Now solving this one now, the first thing you see after the decimal point is 1. So this 1, place it under the first code. The second one is also 1, place it under the second code. The third one is 0, place it under the third code. The next one is 1, place it under this code. So by the time you multiply it, half times 1 is half. 1 over 4 times 1 is 1 over 4. Anything multiplied by 0 is going to be 0. So 1 over 8 times 0 is 0. 1 over 16 times 1 is 1 over 16. So we can easily add these fractions together. When you add these fractions, you then get your answer. So the fractions I have are 1 over 2 plus 1 over 4 plus 1 over 16. So all these numbers that you are looking under, all these denominators, look for their LCM. That is a number they can all go in without any remainder. 2 can go in 16, yes or no?
Yes.
4 can go in 16, yes or no?
Yes, sir.
And 16 can also go in 16.
Yes.
That means the LCM is 16. 2 in 16, 8. 8 times 1 is going to be 8. 4 in 16, 4. 4 times 1, that is 4. Then 16 in 16, 1. 1 times 1, 1. Add all of them together. Answer is 13 over 16 in base 10. So this is how you convert decimals.
So, sir, I have a question. When you were calculating the base values, I discovered that you started counting from this 1101. You didn't start from 0.
Okay, that's a very good question, and I like that question a lot. That 0 is not part of the decimals. Like, see what I'm talking about? If you have a question like, I like that your question, because it will make you understand it better. Like this, if the question is like, convert 101.110 in base 2 to base 10. You know, if you have it like this, you know, in this case it is not 0.
Yes, sir.
Just like the first one, you are going to separate this into 2 to base 10. So let's separate this into 2. The one before the decimal is 101 base 2. Convert it normally. Generate code 1 2 4 101 4 plus 0 plus 1. That gives us 5. Then the one after the decimal it's not going to be 0 point.
Okay.
It's not easy for point to stand alone. We don't normally write like that in maths. You understand?
Yes, sir.
It's correct, but we don't use that method. Just write 0.2. Instead of writing 0.2, we write like a machine. 0.2. In a language a machine can understand.
Okay, sir.
That is the essence of decimal.
Okay, sir.
Now let's come here now. 0.110 base 2. You now convert it using the method we have just discussed. The first thing is going to be 1/2. The second one is 1/4. The next one is 1/8. Since I have 3 things, I can stop. Place this one under this one under this, and this one under 0. So half times 1, half. 1/4 times 1, 1/4. Then 0 times 1/8 is going to be 0. So I will now add these two fractions, 1/2 and 1/4. That will give me 1/2 plus 1/4. My LCM is 4. 2 in 4, 2 times 1, 2, and 4 in 4, 1, 1 times 1, 1. Answer becomes 3/4 in base 10. So the conversion final answer for the whole conversion will now be 5 whole number 3/4.
Yes, sir.
So this is now the conversion.
Okay, sir.
So if what you have before the point is 0 points, then you don't have any business with it. But immediately you have some digits before that 0, you are going to separate the conversion. And this is how you solve this kind of question. What if you want to go back from the fraction and you want to go to the one that is decimal? Like for example, you are getting a question like this fraction now. How do we go about it? Convert 3/4 in base 10 to binary. Do you still remember what binary numbers mean?
Yes, sir.
They are number in base.
Base 2, sir.
Base 2. Number in base 10 are called denary numbers. Denary. In base 10, they are said to be denary. And some people even call them decimal numbers in base 10. Now, if I want to convert this, what do I need to do? Of course, I have 3 up and I have 4 down. I'll just split these 3. Now look at the one you are looking at under. This denominator is what? 4. What are the factors of 4? What are the numbers that can go in 4? 1 can go in 4. Is it not true?
True, sir.
2 can go in 4. Is it not true?
True, sir.
And 4 itself can go. Which of them can I add together in order to get these 3 up?
1 and 2.
1 and 2. Now arrange them in descending order. The bigger number should come first. 2 plus 1 all over 4. So this becomes 2/4 plus 1/4. 2 here 1, 2 here 2. Then this is 1/4. Are you getting me?
Yes, sir.
Okay. What do we need to do is, if you look at it very well, in this addition that you have, you can even stop here. The first code
Yes, sir.
is present for the decimal. You know, there is no 1 for decimal, remember?
Yes, sir.
It starts from 2. So the first one, which is that first code, is present. How many of it am I seeing? 1. So 1 represents it to show that yes, is present. After 2, the next guy is 4. How many? 1 to show that is present. Are you getting me?
Yes, sir.
Because they are decimals, that's why they are in fractions. So it's going to be 0.2. This is the conversion. But let me solve a more technical one so that you can really get it.
Okay.
I think this one is kind of simple. Look at this one. Somebody asked me to convert 19 over 27 to base 3. Convert 19 over 27 in base 10 to what? Base 3. Base 3. How do I solve this one? Now, the very first thing you ask yourself is, what are the factors of 27? 1 can go,
Okay.
3 can go. You always start with 1. Don't say 3.
Okay.
Then 9 can
can
go,
go.
and 27 can also go.
Sure. I want to confirm something. Say factors are numbers that are divisible by a very large number
Yes.
without any remainder.
Any number that can divide another number without any remainder is the factor of such number.
Okay.
Since 3 can divide 27 with no remainder, then 3 is a factor of 27. So how can I select these numbers so that they will give me 19? You know, I told you something under the conversion of integers before we move to these fractions and decimals. Since I'm going to base 3,
Yes, sir.
I still have the privilege of picking a factor twice, but I can't pick it 3 times or more than 3. If I'm going to base 4, I still have the privilege of picking it 3 times. So in this case, I can pick 9 2 times
Okay.
and pick 1. Understand? That's going to give me 19. So I can say 9 plus another 9 plus 1. Everything over 27. This is the only thing I can do. Because if I want to pick 3, then I'm going to pick it more than 2 times, and that is not allowed.
Okay.
You understand? If I
Because
pick
of
9,
the range. the
Yeah.
base.
because I'm going to base 3,
Yeah.
so I must not pick a factor more than 2 times.
So for instance now, like 9, I didn't think we were working with that. We can pick 9 values 9 times.
If I'm working in base 10, I can pick a value 9 times. If I'm working in base 8, I can pick a value as like 7 times.
Okay.
But it must not be up to 8 or more than that.
Okay, sir.
Do you get that?
Yes, sir.
You really understand what I'm saying?
Yes, I do.
You need to get that fact, because if you don't get it, you continue to make mistake. So base 3, you can still pick a factor 2 times. That is why you are seeing 9 2 times there. So this is like, you can turn this on to 9 over 27 plus another 9 over 27 plus 1 over 27. 9 goes in 27, that is 3. So 9 up there. I get what I'm saying?
Yes, sir. But sorry, I want to ask a question.
Yeah, go ahead.
From these values we have here, can we, from these values we have here, 1, 3, 9, and 27,
Yeah.
can we pick 4? 4 is not part of the factor. If we replace 4 here, is this
We can't pick anything that is not a factor.
Okay.
Whatever we pick must be one of the factors of that denominator.
Okay.
So that is it.
Okay.
Okay, let's keep moving. So if you look at this one now, you can say what you are looking at up is 9. You can say 9 here 1. You can say 9 here 3. You can also say the same thing here, 9 here 1, 9 here 3. So I can now, what I have all together is now 1 over 3 plus another 1 over 3, then plus 1 over 27. So remember the coded decimal for base 3. Can you remember? If you are generating for integers 1, 3, 9, 27, and so on.
Yes, sir.
If you are generating for decimals, 1 over 3, you know 1 will not be there.
Yes, sir.
Then the next one, 1 over 9.
9.
The next one, 1 over 27, and so on.
Okay.
So the first code is available.
Okay.
How many times? It's available 2 times. So that means the first code, I will say 0 points, because I can see it's a fraction. That's why it is 1 over 1. Everything is over. Okay. So 1 over 3 comes 2 times. After 1 over 3, the next person is what?
1 over 9.
It's not available in my answer,
Yes, sir.
but I have to show that it's not available. I'll put 0 to show that it's not available.
Okay.
Then the next code is what?
1 over 27.
And that is available how many times?
One
Once. So my answer is 0.201 base 3. That is the end of everything in number basis.
So
What we need to do now is to solve few questions from different schools post-UME past question.